Okay, y'all. So what we're going to do here is we're taking everything that we've done in Unit 4 with rational functions, we're putting it all together. So vertical asymptotes, holes, like the whole, all of it. Okay, so step back for just a second and do a little throwback because we're going to need this when we graph. So how do you find the x-intercept? So we know what the x-intercept is. The x-intercept is here on my x-axis. So x-intercept is where I cross or where I am on the x-axis. And we get this when y equals 0. So we have this ordered pair that's x0, and you're going to substitute or plug in 0 for y. Okay? To find the x-intercept on a rational function, so that's everything that we're doing right now. So on a rational function, what does that look like? We're going to set the numerator equal to 0. Okay? And then when we find the y-intercepts, the y-intercept is when we're going to set x equal to 0, and we get this ordered pair 0, y. Okay, so when I set x equal to 0, I'm going to get my y-intercepts here. Okay, so here's what this is going to look like. Find all vertical and horizontal asymptotes, all holes, all x and y intercepts, and then we're going to actually sketch the graph. Okay, so let's look at this. So I have to ask myself, is it factored? Yes, it's factored. Can anything cancel? Nothing can cancel. My numerator denominator cannot cancel, so I have no holes. But I do still have a denominator, so this tells me that I have a vertical asymptote at x equals -3. So I'm just going to go over here right now at x equals -3, and I'm going to draw in this vertical asymptote. So now I want to find the horizontal asymptote. So what I have here is the same. So I have bottom equals top. I have a Betsy. So bottom equals top coefficient. So my coefficient is going to be 1 over 1. So my horizontal asymptote happens at y equals 1. So I'm going to go over here on my graph, and at y equals 1, I have this horizontal asymptote. So now I have my vertical asymptote, I have my horizontal asymptote. All right? The next step is that we want to find the x-intercept. To find the x-intercept, we substitute this in for y. So here's what this looks like. So this is when y equals 0. So if I go up here, I'm going to say 0 equals x minus 5 over x plus 3. So if I take this and I multiply this numerator over here, this all goes away, right? So what I have is I have x equals 5. Now that's what this says up here. When we find the x-intercept on a rational function, you just set the numerator equal to 0. So here, when the numerator equals 0, I have 5. So my x-intercept happens at 5, 0. And for my y-intercept is when I set x equal to 0. So here's what I have. If I look at my function, I would have 0 minus 5 over 0 plus 3, which gives me -5/3. Now, don't freak out if you see a fraction on here. So what I have is 0, -5 over 3. Now, -5 over 3 doesn't really tell me a whole lot, so I would look at this as -1 and 2/3. So -1 and a little bit more, but not 2. So I have a point here at 5, 0. That's this point right here, 5, 0. And I have this point right here at 0, -5/3. So 0 and almost -2. So I have this point. So because of that, I know that my graph, I know that I have a rational function, so an inverse function, so it's going to look like this. I've got my 2 points over here. So I'm going to approach my vertical asymptote. I'm going to go through this point, and I'm going to go through this point, and I'm going to approach my horizontal asymptote. Because remember, this is going to go on forever and ever. Now, whatever I have in this quadrant is going to be repeated up here in this quadrant. Now, we don't have the exact points, and we're not going to worry about the exact points. What we know is if this is happening in quadrant 4, then on a rational function, the same thing's going to happen in the opposite, on the opposite side. right? So it's like we're reflecting over this new origin, which happens where my horizontal and vertical asymptotes cross. Okay, let's go ahead and do another one. All right, so here's my next one, and I can't do anything until I factor the denominator. So my numerator is x minus 2. When I factor this, I'm going to have x plus 4 and x minus 2. Right, so this gives me negative 8 and positive 2. So I'm good. All right, so what do I know first? I'm going to go down here to wholes, and I see that my numerator and my denominator are going to cancel, so I have a whole at x equals 2. But remember, I have to have the y value of this too. So if this cancels with this, and remember to find the y value, I'm going to plug in the value into what's left. Well, what's left is 1 over x plus 4. This is what's left after I get rid of my whole. So when I plug this in, the y value of my whole is going to be 1/6. Okay? So where's my VA happen? My VA happens at x equals negative 4. So I'm going to go ahead and sketch that in right now. At negative 4, I know I have this vertical asymptote. And I also know right now that I have a whole at 2 and 1/6. Well, 1/6 is tiny. It's almost 0. So I'm going to have a whole like right in here. Okay? So let's go back. I'm going to go back to my original equation up here. And I have bigger on bottom. So bigger on bottom, so I have a bobo on this. So this happens, horizontal happens at y equals 0. So let me go ahead and sketch in my y asymptote right here. So here's my horizontal. Now, if you remember, for x-intercept, the x-intercept happens when the numerator equals 0. Well, look what happens. I'm looking at my factored form. This numerator can't equal 0 because it's just a constant number. And what happens if I look at this, I'm not looking at the original one, I'm looking at my factored form. So once I have everything simplified out, so these are gone, my x-intercept is never going to happen. I have this horizontal asymptote that's here, so I can never hit this x-axis. So my x-intercept for this is going to be none. I don't have one. Now I look here, my y-intercept happens when x equals 0. So when x equals 0, I have this point at 0, 1/4. So on my graph, at 0, 1/4, I'm going to have a little point that's right here. Okay, so what does that look like? I'm going to approach my asymptote here. It's going to curve. It's going to go through this point. It's going to hit my 0, and then it's going to go like this. And then whatever happens in this quadrant reflects over my new origin, and it's going to look like this. And remember, we're not too worried about getting some exact points because the points that I care about I've already gotten in this top graph. All right, let's try another one. Can't do anything until I have this factored. So if I factor the top, I'm going to have x plus 3, x plus 2 over x plus 3. So this gives me 6 and 5, so I'm good. So right away, I see that I have a whole. So my whole happens at negative 3. I'm going to take that negative 3 and I'm going to plug it back into my equation. So this is going to be negative 3 plus 2. So this happens at negative 3, negative 1. And remember, again, I'm not plugging into the original because that's going to give me this undefined. I'm plugging it into the simplified form. So I have a whole right now at negative 3, negative 1. So I have a whole that's right here. Okay, so what I see happened is when this canceled, I have no vertical asymptote because I have no more denominator. So my horizontal asymptote, I'm going to go up here, bigger on top. So I have a bow 2, bigger on top, undefined. So I have no horizontal asymptote. So no vertical, no horizontal. I want to find the x-intercept. The x-intercept happens when the numerator equals 0. So when the numerator equals 0, that's going to happen at -2. So I'm going to have this point right here at -2, 0. And then the y-intercept happens when x equals 0. So when x equals 0, I plug it up in here, it's going to be 0, 2. Now, I didn't write this, but I guess I probably should have. What I have here, after I canceled this out, is I have y equals x plus 2, which is a linear function with an intercept of 2, which is what I have. So the only difference is it's not really going to be a line all the way through because I have to take a break at this hole. So that's what it looks like when it's graphed. Now, let me show you something, actually. So if I was to take this function and type it into my calculator. So y equals, I'm going to clear this all out. I'm going to put this in as a fraction. So my numerator is going to be x squared plus 5x plus 6. And my denominator is going to be x plus 3. Okay? And if I just plot this in a regular window, this is what I see. Right? Well, this is what we just got. Right? With the exception of I have a hole on my graph, and if you look at the calculator here, I don't show a hole at -3, -1. And so even if I made my window smaller, here at -3, -1, I should have a hole. I can make this window even smaller, and I still don't see that hole. But look what happens if I do second trace and I go try to find the value. So what is happening when x equals -3? Okay, so let me go back to that, show you one more time. If I go to option 1, which is value, it's saying, give me the answer when x equals what? When x equals -3. Okay, so we know we have a hole. So look what happens. It says x equals -3, y equals blank. Because even though you can't see it on the graph, there really is a hole there. The TI-84 will not plot the hole. And I'll tell you, this isn't just a mistake, because I'll show you what happens. We know that when x equals -2, y equals 0. So let's look at that, just so you can see the difference. -2, and this tells me that it equals 0. So if you want to check this, and you look at it, and you're like, okay, this is a graph, but there's not a hole, well, the calculator's not smart enough to show you a break in the graph. So that's why you have to do it by hand. Don't rely on your calculator. Okay? All right, last one. Okay, I have to factor both numerator and denominator. Let's see. Let's see, this is only going to be 5 and 1. I want 11, so this is going to be plus 5 and plus 1. So this is going to be 10 plus 1 is 11 and 5. Okay, so first thing I see is that I'm going to get rid of my x plus 5 value. So I have a hole, and that happens at -5. Now remember, I have to take this value and plug it back in. So I'm going to write my new equation. My new equation now is 2x plus 1 over x minus 5. So once I cancel this out, this is my new equation. So when I plug -5 in, I get -10 plus 1 over -5 minus 5. So I have -9 over -10. So this happens at 9/10. So my ordered pair is -5 and 9/10. So this is my hole. Now, this is almost 1. So if I go over here to -5 and almost 1, I'm going to have a hole right here. Okay, so let's go back to our equation. Here's my new equation that's back down here. So I know that I have a VA at x equals 5. I still have a denominator on this one, so x equals 5 is going to be my vertical asymptote, so I can just go over here and draw this right away. All right, I'm going to go back to my original equation. My original equation, I have bottom equals top coefficient. So I would have 2x squared over x squared. So my horizontal asymptote happens at y equals 2. So HA happens at y equals 2. So x-intercept, so remember x-intercept is when the numerator, one more time, numerator equals 0. So here's what I have. 2x plus 1 equals 0. So x equals negative 1/2. So negative 1/2. 0 is my x-intercept. So it's going to be right here. And then the last one, y-intercept happens when x equals 0. So if I plug 0 in here, I plug 0 in here, I'm going to get negative 1/5. So 0, negative 1/5. So right here. All right, so what does that look like? It's going to look like this. I have a hole right here. Should not have been quite that curvy. It's going to go down this way. And then this one's going to be up here, and it's going to look like this. This should be more, there we go. That looks a little bit better. Okay, lots of things going on. We're going to practice this quite a bit in class, but make sure you come and see me if you've got any questions about all of these little individual parts before we put it together.